Well, welcome to this online revision session for AQA M2, in which we'll be looking at the June 2010 question 8 on circular motion but in a vertical plane. Well, as you can see in this particular question, we have a string of length 3 meters and a particle is attached to the end of it, and when it's at P, its speed is v, and it follows a section of a circle through an angle of 15 degrees until it gets to the point Q, and the particle momentarily comes to rest at Q. So it's like the first part of motion of a pendulum. Okay, and we have been asked to find the value of v. So for this part of the question, typically for a vertical circular motion, we would analyse the energies. So we need to consider the energies at P and then the energies at Q. So we can say that the gravitational potential energy at P we can define as being 0, our chosen 0 reference point. And the kinetic energy will be a half m v squared. When we get to Q, the gravitational potential energy will have increased because we will have risen, and that will become mg. Now we've got to calculate the level to which it's risen, so it's risen from here to here. So we know, since this is a right angled triangle where this length is 3, that from O down to this point is 3 cos 15, and from O down to P is 3, so this difference must be 3 minus 3 cos 15 degrees. Similarly, the kinetic energy, since it has come to rest at that point, must be equal to 0. Now we can use conservation of energy because the only external force is the tension in the string, but the string is always perpendicular to the motion and so will do no work, so the energy must be conserved. So we can then say by conservation of energy, the energies at P must equal the energies at Q. So a half m v squared must equal, well, we can see we can take that factor of 3 out of there and get 3 mg 1 minus cos 15 degrees. Well, at this point we can then see the m will cancel out from both sides, so that leaves us with the fact that v squared must equal 6g times 1 minus cos 15 degrees. We know that g is typically taken as 9.8 meters per second squared, so we can substitute that value in and then square root the answer to give us the value of v, and so if we do that we will get an answer of 1.42 to 3 significant figures. Okay, and that will be meters per second. 4 marks for this question. So analysing the energies and obtaining the correct statement through conservation of energy will give you a method mark and an answer mark at this point. Simplifying down to some next suitable expression for v squared will give you a mark. and then finally for obtaining the correct answer. I'll give you the final mark for that part of the question. Part B of the question then asked, when the particle is at rest at point Q, the tension in the string is 22 newtons. Find the mass of the particle. So we know that the tension at this point is 22 newtons. If the particle is stationary, it's at rest, it's therefore in equilibrium. In the direction of the point OQ, or the line OQ I should say. Okay. Because if the velocity is 0, or the speed is 0, there is no acceleration towards the centre of the circle. So the component of the weight must be balanced, or in equilibrium, with the tension. So down this way, we know this angle here is 15 degrees, so mg cos 15 is acting in one direction and t is acting in the opposite direction. So we know that along that line that t must equal mg cos 15 degrees. Okay, and it's only because it's at rest, because the acceleration towards the centre of the circle is 0. Right, your mv squared over r is 0. There is still a tangential component to mg which will be accelerating the particle back down through the circle at that point. And so we know that t is 22, and that must equal mg cos theta, or cos 15 degrees, and we want m, so if we rearrange this we get the fact that m must be 22 over g cos 15 degrees. And that gives us an answer of 2.32. And one assumes that must be in kilograms. Three marks for that question. For obtaining the correct relationship between t and the component of the weight, I'll give you a method mark and an answer mark. And then for obtaining the correct value for m, gives you your third mark. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.